Okay, so we're on chapter 3.5. We're talking about complex numbers. Let's first define a complex number. A complex number is an expression of the form a plus bi. A is the real part, b is the imaginary part, I is the imaginary unit. So a plus bi, where a and b are real numbers like 7, -3, 5.9, pi, and I squared is defined to be -1. I is called the imaginary unit and has the property that I squared equals -1. Now what does a complex number look like? A plus bi, well, it could look like 3 plus 4i. 3 and 4 are real numbers, a and b. 3 is what we call the real part, 4 is the imaginary part. Okay? This is an example of a complex number, 3 plus 4i. Here's another one. -6i is a complex number because it's 0 plus -6i. 0 plus -6i. This is actually one that we would call purely imaginary. And the reason for that is that there's no real part to it, just purely imaginary. And the last one, this is also an example of a complex number because it's of the form 3 plus 0i, where there's 0 imaginary part. Okay. So again, these are all examples of complex numbers. How do we first talk about operations on complex numbers? Well, if we want to add two complex numbers, what we do is we add the real parts and we add the imaginary parts. So just like adding like terms, a plus c is a plus c, bi plus di is b plus di. Just like adding like terms. There's two terms that have I, so it's b plus di, and two terms that are just real, add the real numbers. If we subtract, we just distribute, so we'll have a minus c, so a minus c. We'll have bi minus di, so plus b minus di. Okay. If I want to multiply two complex numbers, what I do is I distribute my FOIL, if you will. So first plus outer plus inner plus last, bdi squared. Notice that I squared equals -1. So wherever I see I squared, I replace it with -1. So this will equal AC minus BD. AC minus, because -1 is minus BD, plus AD plus BCI. Okay. So, rule of thumb, when we multiply, all we have to do is distribute. When we divide, we don't like, when we divide, what we want to do is we want to multiply both top and bottom by what we call the conjugate. The conjugate to c plus di is c minus di. The conjugate to c minus di is c plus di. And so I multiply both top and bottom by c minus di. And what happens is, we get a difference of squares down here, so we'll eliminate the I. We'll get c squared, right, minus cdi plus cdi. Those two cancel, so we'll get minus d squared I squared. But as we know, d squared I squared is really just, I squared is equal to -1. So that'll actually equal be c squared plus d squared. And on top we FOIL, we get AC, and then we get first outer minus ADI plus BCI minus BDI squared. But we know I squared equals -1. So it'll be AC, -1, and negative BD is plus BD. Okay, and then I'll have plus BC minus ADI all divided by C squared plus D squared. Okay, this looks a lot more complicated than actually doing operations on complex numbers. So let's take a look at a couple of examples of doing operations on complex numbers. So for example, suppose I have this, and I want to perform operation and suppose I have 3 plus 4i minus 6 plus 7i. Well, all we do is we look at the real parts. The real parts are 3 and 4, add like terms, so I have 3 take away 6 is -3. 4 take away 7 is -3, so -3i. Just by combining like terms. That's subtraction. Suppose I have a multiplication problem. Negative 2 minus I times 3 plus 2I. Well, we FOIL. If I FOIL, I'll get negative 6 minus 4I minus 3I minus 2I squared. Negative 4I, negative 3I is negative 7I. So negative 6, negative 7I. I squared is negative 1, so it'll be plus 2. This becomes plus 2. So it's negative 4 minus 7I. Okay. Finally, if I had an example of division, suppose I had 2 minus 7I divided by 5 minus 2I. We multiply by the conjugate. The conjugate to 5 minus 2I is 5 plus 2I. 5 plus 2I. If I distribute the bottom, I'm multiplying by that. If I distribute the bottom, I'll get 25. First, outer and inner are going to cancel. Positive 10I, negative 10I cancel. I'll get minus 4I squared on top, or on bottom. Distribute on the top, I'll get 10 plus 4I minus 35I minus 14I squared. So if I notice that I squared is negative 1, negative 1 times negative 14 is positive 14, 14 plus 10 is 24. I'll get minus 31I divided by I squared is negative 1. Negative 1 times negative 4 is positive 4. 25 and 4 make 29. So this is actually in the correct form if I write it this way. 24 29ths minus 31 over 29I. It's got the form A plus BI. Alright, so square roots of negative numbers. If we have the square root of a negative number, so negative R is actually a negative number, then what we can do is realize that I have the square root of negative 1, which is I. I've got this rule that I squared equals negative 1, so therefore if I take the square root of both sides, I equals the square root of negative 1. So this allows me to deal with situations where I have a negative inside the radical. Okay? So if I take a look, I just want to look at a couple examples. Suppose I say simplify. And suppose I have square root of negative 12. Okay, suppose I have the square root of negative 12. Okay, so the first thing that I want to note is that this is equal to square root, of negative 1 times 4 times 3. Now we know the square root of 4 is 2. We know the square root of negative 1 is I. So we'll have 2I root 3. The square root of negative 1 is I. The square root of 4 is 2. 3 still left in the radical. Okay? Suppose I have another one, number 2. Suppose I have the square root of, let's say, negative 45. Okay? Well, this is equal to the square root of negative 1 times 9 times 5. The square root of negative 1 is I. The square root of 9 is 3. And then I have the 5 left over. Okay? So it allows me to simplify expressions that normally are not real. Now that I have these complex numbers, I can describe what the square root of negative 12 is. It also allows me to solve finding the complex solutions to equations like this. Normally, that if we solve for this, we'd subtract 16 from both sides, get 4x squared equals negative 16. Divide both sides by 4, and I get x squared equals negative 4. Take the square root of both sides, put a plus or minus. And I get x equals plus or minus square root of negative 4. Now, normally, we don't like square roots of negative numbers. However, we note that now we have this idea that the square root of negative 1 equals I. So this will be x equals plus or minus, and the square root of 4 is 2. 2i. So there are two solutions to it, positive 2i and negative 2i. Let's take a look at one using the quadratic formula. Suppose I want to solve this equation. Well, if you use the quadratic formula, identify this is a, that is b, and that is c. And x equals negative b, so positive 2, plus or minus the square root of b squared, minus 4 times a, which is 2, times c, which is 1, divided by 2 times a. Okay, 2 times 2. This will equal 2 plus or minus 4 minus 8 is negative 4 divided by 4 which equals 2 plus or minus, as we know, negative 4, square root of negative 4 is 2i, square root of 4 is 2, square root of negative 1 is I, so 2i divided by 4. If I break this down as a fraction, it'll be 2/4 plus or minus 2i over 4, which is 1/2 plus or minus I, or just say 1/2 I. So there's two solutions to this equation: a half plus a half I, a half minus a half I. This allows us to give complex solutions to equations that we normally didn't have real numbers as values for solutions.